Hello everyone. Thank you for attending to our presentation. Should it start?
It's loading. It's going to be better than this. Right? All right, so while we are waiting, I didn't know that he was in military, so this gives another perspective. All right.
Okay, so let's start. Today we will present how eMAG's switched from a data warehouse, from a traditional data warehouse to a modern data lakehouse architecture. I'm Marius Grumazescu. I start working with big data immediately after finish my master degree, when I learned a lot of big data. And after that, in the last 5 years, as you can see, I work with multiple technologies in big data and diverse sectors like finance, consultancy, and retail.
Yeah, we had a brief introduction, so I will not talk about myself for too long, but yeah, I'm 2 years in Cloudera. I'm supporting eMAG and other customers from Poland and Eastern Europe. And yeah, it happens that I always used to work for companies that are basing their solutions on open source projects. So yeah, so let's go into the main topic of the presentation. So let's see how we started working with eMAG. And what are you be talking about today?
Today we were talking mainly about how when we switch from the traditional warehouse to the data lakehouse architecture, we managed to solve 3 big problems. First of all was how to ingest such amount of data as fast as we can in a data lakehouse where multiple users can access the data and build their reports upon them. How to empower the analyst and how to give them a possibility to work with big data technologies, and of course how to provide and organize that environment in a proper manner in order to be accessed very fast. The most important thing for us was ingestion, like I said, and how to optimize this process in order to make it really reliable and very actual for the people. In the second phase was how to create this architecture and how to empower the user, and of course, in the last phase, how to organize the things on layers and as in a such manner that every team or every part of the organization will be able to access only the information that they need and only their resources that they need, not to overload the cluster.
So let's take a brief look at how we started working together. So actually the cooperation between eMAG and Cloudera started before I joined Cloudera. I believe before Marius also joined, yeah?
Yeah.
So we were not at that time, but what we know, it was around 2020 that the collaboration started. There were some plans to invest in a big data platform. The selection was Cloudera, and I think around 2021, the first cluster was built.
Yeah.
Exactly 1 year ago, we upgraded, well, eMAG actually upgraded to the latest release at the time. And since that, the platform has been running on that release stable, and we kind of stabilized the environment. Yeah.
Yeah. Thank you. Let's see why we choose the data lakehouse. In the first place, we needed analysis in real time on big amounts of data. The second time was that we needed to have fresh data, not only to ingest the data, but have them as fresh as it could be, oftentimes required in real time. as the users were used in MySQL databases or relational databases before. And second of all, we need agility in always changing requests from the business sides. As you can see, there are multiple areas, business lines in eMAG that are requesting the data, and upfront are created dashboards. As I mentioned before, we are ingesting the data from multiple sources, and we also expect a higher increase of data over the time. For example, 2.5 years ago, when I joined eMAG, there were about 2 million offers. At that time, we're expecting next year to have about 20 million offers. So in less than 3 years, we also expect 10 times of data as well. Another important decision was to how to make very good decision over the data, having in mind that there are multiple areas where people are doing the same reports. So we had to structure them in one place. Everyone should know where to find which data they need, not to be multiplied over the cluster.
Yeah, okay, so that was why they chose the data lakehouse architecture. Why Cloudera, briefly?
Most important thing is that we have a vast amount of data, and the data needs to be processed by a large amount of users. Those users will query. For example, if you're going to the cloud, that was when we also had it on the table. We were consuming a lot of resources analyzing such amount of data. Also needed to have a really quick option to onboard multiple teams, not only that are processing the data, but also they are viewing the data or querying the final data in the gold layer, for example. And we were also expecting a lot of jobs. We didn't know that time how many it will be, so we needed to have some resources at disposal and not care about the cost, but know them upfront. Of course, one another important reason was that in big data technologies, the technology are always changing, and we needed a possibility to test some other additional tools, not only that are maintained by Cloudera, but additional tools and integrated with those tools, mainly open source tools. That's why we have tested a few, not only tested, but also implemented in our ecosystem.
Yeah, so as you probably know, Cloudera is quite open platform, open in a sense that it's based on open source technologies, but open in a sense that you can integrate it with other tools as well. And you will see later that actually eMAG is using also tools other than Cloudera. I want to highlight the word experiment because the guys do experiment with the tools a lot. And actually they are one of the customers that are progressing very fast with our releases. So at Cloudera, we have two kinds of releases. We have so-called long-term stable releases that we support for 4 years. And we are saying, okay, this is a stable release. You can receive security fixes for it. But there is also a second type of release which changes more frequently, where we are exchanging underlying projects. And it happens that eMAG guys are choosing the most innovative release, so they are always experimenting and moving forward with the technology. Yeah.
Okay, so I was talking before about data variability. Most of our data are coming from MySQL tables, which do not fit anymore such amount of data or are hardly processing the data in them. But of course, we are ingesting data from MSSQL, AVC, BigQuery, and Kafka or CSV. This shows that we are always ready to ingest new type of data and are open to discuss new possibility and adapt as the business requires.
Yeah. So these are the types of data that you are processing, but what is actually behind those data?
Yeah, that we will see in the next slide. Thank you, Michał. This picture presents not all, but part of the business lines in eMAG that are using the data. Here, we can see that those business lines are not all of them consuming also the processing power of the cluster, but they are using some additional tools to query the data or create dashboards in the final layer, yeah, where the final data for presenting it are stored. One of the projects, for example, it's orders, which was created in multiple teams, in multiple business lines, having different connotation. For example, calculated different in different teams, and we managed to have it in one place. And from the base project, for example, multiple teams can adapt it to according to their needs.
Yeah. Okay, and if you can give us a perspective on a scale, how much is that in total?
Yeah. Currently, we have managed to onboard about 10 teams in our infrastructure. When I'm saying that we onboarded, it means that those teams in the business intelligence department are also using the processing power, and mainly all the tools that we, a small team, big data, were able to use till we made it available to all the teams. Till now, in the last 5 months, we managed to replicate, migrate, in fact, about 200 pipelines, meaning projects from Click, for example, into Airflow pipelines, which are now running faster and can be better observed when it crashed, reloaded, and so on than it was before. And of course, we are using about 2 petabytes of data at the moment. Most of them are files stored in HDFS, but for real-time, for some real-time projects, we are using Kudu. Although we cannot use Kudu for all the projects, since it has its limitation.
Yeah. And if we have a look at the big picture, like if you need to show the whole architecture, let's dive into this one. Yeah.
Yeah. So this picture was presented by my colleagues last year too. Here we were last year at some point. Of course, not all these tools were used in production. Most of them were used to test and see which one fits best for some specific project. We tried to reduce as much as we could, and we did it. And I'll present that reduce of the tools in the next slide. Also, this reducement of the project will also help us in maintaining faster the platform and not having too much to fix, repair, and so on.
Yeah. So on the ingestion side, where you are putting the data into cluster, what options have you explored?
Yeah. Till last year, we tried different options. First of us, and most obvious for us at the moment, since we already work with this option before make the platform available for the user, was Spark writing into Hive tables, which behind have Delta Lake format. This wasn't a very, very good solution for us because we couldn't update the tables using Impala. Most of our users in the business intelligence department wanted to use instead Spark Impala as a next step from MySQL. Yeah, and after that going to PySpark or some other tools. Yeah, it was quite hard, even though, I mean, we couldn't do it with Impala, but we could do it with Hive engine. having in behind MapReduce or TES, but of course this is updating very hard. This is working very hard, as you probably know. MapReduce and TES are very slow engines, so it didn't help us too much. Then we tried Nifi writing into Kudu, and we really thought this is the chosen solution, but we quickly found out that it couldn't fit. We couldn't fit to Kudu as much data as we needed. Kudu can handle about 10 to 50 partition per tablet server, or we have a finite number of tablet server. So we still use Kudu, but for some specific projects. And lastly, we tried to write with Nifi in Phoenix table. But even though the updates and the inserts were done pretty quickly, it was very slow for analytical queries, and we also abandoned this idea.
Yeah, so what is important to note is the numbers that you put on the slide is like the chosen technology worked only for like 20% of use cases, but didn't work well for the remaining 80, right? Nifi Kudu maybe worked for 50% but use cases, but for the other 50%, it wasn't that well. So as you can see, the guys are exploring a lot of options, and then the final solution is kind of presented on the next slide, right?
Yeah. So this is our currently our main processing solution. We have a few by side, but we will all migrated to this solution. As you can see, we're ingesting data from multiple sources, and we tried as much as we could to reuse the projects and the tools that we used for a type of file to ingest for other tools as well. As you can see, when we are ingesting from Google or AWS buckets, we're getting the data to NiFi, sending them to Kafka, and reuse the same Spark job that will write the data into the bronze layer. In the first place, all of this, of course, managed by and orchestrated with Airflow.
Yeah, so as you can see, there is no one solution that fits every use case. It's usually that you need to have a couple of paths, couple of different solutions to ingest the data. Let's see what happens afterwards. So we ingested the data, and then you go into the different layers. Can you talk a bit about that?
Yeah, sure. Okay, so as we presented here, you see on the left side, it's the bronze layer where the data comes from any type of external source. Yeah, in the first phase, we either write the data directly into the daily tables for some specific tables or for some specific sources, or we write the data into some archive tables. And from there, a Spark merge process, it's running and updating the daily tables. Of course, you will say, yeah, but this is time-consuming. Of course, it is time-consuming, but it's our best solution to have it also updated in a fastest way and have it also freshest as we have it in the relational databases. From the bronze layer, this part in the left part is mainly managed by the ingestion team, by the big data team. After that, to have the data in the silver layer, multiple users from business intelligence department are querying data first or not first, depending on the project. They are querying the data either with Impala or Spark, and writing the data in the silver layer. And from the silver layer, multiple users, not only the BI intelligence department, have access to this data and write them into the gold layer, upon which they can create reports, they can send the data in different other sources, and so on. You can see that from the silver to the gold layer, there are multiple type of tools that can query those data, depending on the project and the department.
And I also think that depending on the skills, right? Because one person can be familiar with SQL, so he wants to write in Impala, and the other person will be more skillful and can write in Spark. So that's why you can see two engines on the same flow. Yeah. And how not to lose data on the way. So what do you do about data quality?
Yeah, that's also an important and hot topic in big data ingestion in general. We wanted to find a solution that even that will not fit all the cases, to fit as much cases as we could. So we did counts on different segments in the data as well as in the source compared to the destination. For example, we take from 85 for 90%, but not only one interval, we can take it multiple intervals. This is done immediately after the merge is done, the merge from the archive tables into the daily tables. And also we do hash, not to be consistent with all the data, not with the count of the data, because only one column can be changed and the number is the same. We do hash for the same interval, but at a row level. So we compare every row in some specific interval or some specific intervals. Every time a quality check is crashing, we get notified and we invest why it happened. And also we inform the users that are consuming data in the data lakehouse in a dashboard about when it was updated last time a table and if there are any problems regarding quality checks.
Yeah. So I believe there is some automation after the ingestion. There are jobs that are doing the quality checks, right?
Yeah.
Okay. And if we go into automation of your daily work, so if you need to write those Spark or Impala jobs, how do you do that?
Yeah. Of course, another problem, let's say, issue at the start of this project was, okay, you brought us the data, but how can you test it? Do we write code directly to production? So we came with this solution. We have Zeppelin and Spark and also Impala from Cloudera. In Zeppelin, for example, we created for everything in BI different interpreters. They have a limited queue of resources. They are writing the code there, writing into an interpreter like VS Code and push it to the development branch. As you can see, from the development, once you have the code in the development branch, it will automatically merge and you can see your DAG and also which triggers your process in behind in an Airflow interface. From there, you can schedule, play with it, and so on. And of course, once this is all good, you can merge the development branch into the master branch, and you have it in production. And where in production only some service users have access to run the queries. Of course, this applies also for Impala. Not all projects are a good fit for Spark, and that's why we are still using Apache Impala, triggered and orchestrated, Apache Impala script, triggered and orchestrated by the same Airflow.
Yeah, so whatever you write is later automated and run into a DAG, and it's managed by Airflow, right? So another, I think, important aspect is when you think about the big data platform is how you maintain the security, because you have, as you can see, you can have a lot of tools stitched together. You have a lot of teams that are trying to work on the data. So how you solve that problem?
Yeah. At the beginning, when we started with Cloudera, we were a small team, so every new join or leave from the team was pretty easy to onboard. But when you face, let's say, 50 users starting all in the same time, this became a problem. We managed to solve this problem with Ranger, again from Cloudera suite, which allowed us not only to give access on the data, but also prioritize the resources even in Impala by allowing some user to run only on some queue, yeah, and competing with its own colleagues for the job, either in Spark the same way.
Yeah, so Ranger, maybe some of you know, is like a centralized tool for security in our platform. And it not only allows you to assign privileges and access rights to users, but what is really important, it also maintains the audit. So whatever is happening on the platform, whoever is accessing the data, this audit data is automatically collected. And then later the admin, if something goes wrong, can refer to the data. Yeah. All right. So okay, so this was the high-level picture, some architecture, and let's take a look at the real business use case. Yeah. So how does working with Cloudera from the business user perspective looks like?
Yeah. As you may know, the business still likes, I suppose not only at eMAG, still likes to write CSVs or Excel files. And this small business case, it's one constructed to solve one of their problems. As you can see here, a specific CSV file can be ingested directly into the gold layer, so the business user can access the gold layer through some other tool like Dremio or Nime and get their data from there, do some processing and, I don't know, show it in a dashboard, or can use that file to be ingested in the bronze layer, from which we he requests to some business line team, yeah, some business intelligence team to join them with some other table, create a bigger project for it, and orchestrate it with Airflow, and again have it in the data in the bronze layer.
So just to give a reference, so the CSV file can be, for example, information about the products that will be on sale for next week or whatever period of time, right? So there is a business person who prepares that. Yeah, there will be a promotion, there will be some discounts. He creates a simple table, export it to a CSV, and then somehow this data needs to get into the data lake, because obviously the business person is not really ingesting anything directly. Yeah. Okay.
Okay, so we talk a lot. Let's see why this solution helped us so much. Before this solution with Data Lakehouse, most of our users were running queries in Click that were harder and harder and took longer and longer to process as the data increased. For example, some specific jobs were taking about 15 to 20 hours, and running them firstly in Impala, because we provided only Impala in the first place. They saw a huge improvement, but after running in Spark, they saw an even better improvement on this. What I want to explain here is that not only for the larger job we have improvements. We found improvements from Click to Impala, even from small and medium jobs. But there is no huge improvement, or it's not a huge improvement when we take into consideration small and medium jobs and compare Impala with Spark. Overall, there is improvement where you go from Click to Impala, either Spark.
So again, this shows that obviously this slide can show you that, okay, so with Spark you can be the fastest, but actually you need to consider that some people don't have Spark skills. They want to just write SQL query. So again, you will have two options to work with your data.
Yeah, over the year we also have had a lot of challenges. First of all was that when made Impala available for the entire users, we got stuck quickly. A lot of users were running queries larger and larger. They thought that they can run anything on any type of data. So we had to split that queue in multiple queues, either that are queues for teams, where only some users are allowed to run on that queue, or either on small, medium, and large, and advised and documented why you should run a query, how you can investigate a query in Impala to find the proper queue, not to impact the other colleagues or the other teams. Yeah, we also tried the last year DBT. It was a good solution for us, but at that moment was not fully maintained by Cloudera, and we needed to give up on it. But it's a very interesting tool, and we think once Cloudera makes it available, we'll start again. Airflow, again, pretty much the same problem as we had it with Impala, in sense that we've installed Airflow on one big server, but when we come with 50 users and multiple queries and tasks, multiple DAGs and tasks there, it got stuck quickly, so we moved it to Kubernetes. Yarn, since till now, we migrated some projects, about, I say, 10 to 20% from Click to our infrastructure, and we seeing that the resources are not enough anymore. We can see that soon the resources will not be enough, and that's why we somehow advise the users and allow them a smaller queue in order to do performance improvements on their projects. Of course, this is a trade-off because the business requires very, very fast, and you don't have the time to make the project very fast and also very, very performant. Yeah, and the last one issue, it's about ingestion. When we could not agree with all the owners of the table that we need to ingest to keep a format or not to update the tables without announcing us, or not to change the schema and so on. So we needed to adapt to all of these, all of their tables, because we understood that those projects, their project, weren't so easily to change over the night just to make the data available for us.
Yeah, so whatever solution you come with for ingestion, if somebody is changing the source without notifying you, it will fail, right? So I think there is a lot of discussions about data mesh approach, where you should have data as a product, right? So in the ideal scenario, the people that are maintaining the source tables, they should treat them as a real product, and this product has some certain SLAs. This product can create some notification if something changes, right? And this is the way of thinking that we should implement for this type of use cases. Yeah. All right. So summing up, let's move to lessons learned.
Yeah. As you can see, the biggest problem for us was that there are multiple tables, type of tables, and one solution will not fill all of them. You have to find workarounds and create custom projects for every time. Even that we showed in the beginning that we tried as much as possible to reuse the same project or to make it custom, but to fit more and more formats. Again, we created the infrastructure, we provided the infrastructure to the business intelligence users and so on, but they didn't know to work with these new big data technologies, and we needed to advise them to create documentation, to create templates, and guide them in the first place to have a few projects, and after that it all come along. Another problem was that being a small team, we weren't so. We had the data in multiple places in the data lake or so, but when it comes to having such amount of projects, onboarding such amount of users, we needed to have this very, very well organized. And as I showed before, we have Hive tables in different layers.
Yeah, so the most important aspect for me here is the templating, which really translates to onboarding people, right? So no matter what platform you build, if the users are not skillful and they don't know how to use it, this will fail. So in a lot of discussions with our customers, we see that onboarding starts to be the most important topic, right? Let's make sure that people who are actually going to use this platform, they know how to use it, know where to log in, they have access, etc. Yeah. All right. So moving forward, what we are planning for the future?
Yeah, the most hot topic for us in the right moment is that how to make analysis in real time. And for us, we think a very good solution would be Apache Flink, since the requests from the business are increased in this real-time analysis. So we're taking into consideration to onboard it soon. DBT, once it will be available from Cloudera, because it is available, but it's for now in cloud. So we also need it in our infrastructure in on-prem. Of course, we are exploring the cloud solutions for maybe part of the project, or why not the entire project if we see that it's feasible. Not only Microsoft, Google, and AWS, but also the public cloud solution from Cloudera, and Data Hub even, for data lineage. Even that it's a project at the beginning. Let's say we have to onboard the data and user, and after that we can also adapt to it.
So more focus on metadata, yeah, in the data lineage aspect. Yeah.
Yeah.
Okay. So let's go to the summary.
Okay, summing up, we have about 30 projects migrated till now from Click to our data lakehouse solution. We are, as we say, it organized in proportion of 85%. We still have something to solve. We're ingesting currently 6 types of data, but we're expecting more, and we are prepared for that. And we can see an improvement of at least 4 or 5 times compared to the traditional data warehouse in processing the data and delivering it to business.
Okay. And it looks like we finished on time. So yeah, we are happy to take any questions. I know there has been a lot of technical information, but Marius is happy to explain more details if needed. I'm happy to also talk about Cloudera product. Yeah, go ahead.
Hi, Marius. First question for you would be, is eMAG planning to extend in other countries?
Yeah, of course. There are more and more users coming, yeah, into the eMAG platform, buying from eMAG, and also not only eMAG, but you see that maybe you know we have side projects like Freshful, Same Day, and so on, TAS, that at some point need to be merged into some projects. So we need to have data from both of the sources.
Okay, and a technical question. You speak a lot about ingestion. And
yeah.
The problem for ingestion in general that
yeah.
we all of us have. And yeah, I want to understand what optimization you are doing on the table, how you ingest the table, are partitioned or not, what kind of the type of the file, only CSV or also other type?
Yeah. It doesn't matter what type of file we ingest. We will write them into Hive table. We only use Hive for Metastore, but in behind there is Parquet format with Iceberg format. And why we choose this solution is that it was a great fit for us because we could do asset transaction on it, and it was the only tool that could accept only format that could accept asset transaction, and also be able to be queried by all the tools that we have, like Dremio, Impala, Spark, Nime, for example, and so on. With Delta Lake format, we also tried, but we got into some issues, and of course Kudu, but Kudu couldn't handle such amount of data.
Okay, thank you.
You're welcome.
What's interesting, since Marius mentioned Iceberg, and you could see that we had it on slide, is when they installed the latest release last year, Iceberg wasn't available on the Cloudera platform, but they made it work. So they did the job for us, and now Iceberg is available in the new release that we just released a couple of weeks ago. But this again shows, if you experiment, if you are not afraid of new technologies, you have a lot of options.
Do we maybe have another question for Marius and for Michał? If not for the moment, I'm sure that you will catch up with them during the networking break. So
Yeah,
thank
go
you
ahead.
very much, Marius.
Thank you very much
Michał.
Thank you.